Hello wonderful person, this is Anton, and today we're going to return and discuss one of the most debated worlds in astronomy, the exoplanet referred to as K2-18b, an exoplanet officially discovered by the Kepler mission, and a planet that you might remember because it made a lot of headlines a few years back. This was the planet where scientists were claiming the discovery of life, or specifically signs of life, inside some kind of a stinky alien ocean, involving a gas referred to as DMS or dimethyl sulfide. But ever since the original discovery, there's been quite a few additional studies and additional papers, including the most recent observations using radio telescopes, in order to see if there are any unusual radio signals coming from here, and if there's any chance someone is trying to communicate with us. And so in this video, let's talk about some of these recent updates, discuss what this planet is all about, and possibly find some conclusions. But first, in order to understand why so many astronomers were obsessed with this planet, we have to take a brief look at its basic properties. And that's because this particular planet is what we actually refer to as a sub-Neptune, or a mini-Neptune, that's approximately 2.6 times the radius of Earth and is approximately 8.6 the mass. In other words, it's a planet that's more massive than a terrestrial planet, but much less massive than Neptune and Uranus. But more importantly, it seems to orbit a relatively quiet, cool red dwarf star, and seems to be right in the middle of its habitable zone, basically suggesting that the temperatures here are perfect for any potential liquid water to exist on the surface. This was actually a kind of a prototype for a new classification of planets referred to as Hycean worlds, a hypothetical class of planets with hydrogen-rich atmospheres, very likely covered in the global liquid ocean hundreds of kilometers deep. Although pretty quickly some scientists started questioning this and even proposed that such planets potentially do not exist or cannot exist for several reasons. You can learn about all of this in one of the videos in the description. But additional observations from telescopes like the James Webb did potentially discover methane and carbon dioxide in its atmosphere, while notably showing a complete lack of ammonia. And while normally in the world of planetary sciences, that specific combination is very often a fingerprint for some kind of a hidden ocean. Either way though, it was not entirely clear what this planet was like, but it was becoming more and more exciting every single year. And this excitement reached its peak a few years back. This was when a separate team from England announced a potential discovery of a molecule referred to as DMS or dimethyl sulfide in the atmosphere of this planet. And the reason this was exciting is because here on Earth, DMS is almost exclusively produced by some kind of life, usually marine plankton. And so the hinted presence of this molecule in the atmosphere was technically a big deal. But as we've discussed in those previous videos, in science, when you have these very big claims, they obviously require extraordinary evidence. And so additional observations and additional analysis very slowly started to kind of dismantle this hypothesis and a lot of these propositions, with some researchers first finding that the data was actually just a little bit too noisy and did not produce definitive results. As a matter of fact, in this case, DMS could have actually been a lot of other things, and other teams, like the team from University of Colorado Boulder, even questioned DMS as a potential biosignature or as a potential marker of life. And that's because their experiments were able to recreate this abiotically without any life or bacteria, just using photochemistry in the atmosphere, with other teams such as a team led by Gabriela Di Genova from University of Grenoble even discovering that it can technically form in space by itself and in various interstellar environments, including various nebula. As a matter of fact, it was even confirmed to exist around certain comets, with the most probable pathways involving reactions between methanol and various types of radiation. This was actually studied in the context of the galactic center cloud, where DMS has been previously detected. And so a lot of these additional studies now hinted on DMS not actually being a biosignature at all, or at least not a biosignature that's definitive, because so many natural chemical reactions seem to be able to produce it as well, with the overall conclusion being that the universe seems to have multiple recipes for creating this molecule, and astronomers have to be much more cautious before making these grandiose announcements. You can learn about this in a study in the description. And so these initial claims by Nico Madhusudan from Cambridge that continuously suggested that DMS here was very likely the result of life have now been critiqued and pretty much disproven by most independent studies. with the overall conclusion being that this narrative of this high-seen world superplanet essentially just being hype and lacking scientific consensus. But this did not stop additional researchers, and specifically SETI researchers, from basically saying, okay, well, we might still want to take a look at this and see if there's anyone trying to reach out and communicate with us, because maybe it is life, and specifically extraterrestrial intelligence. And so since K2-18b is still a prime candidate for habitability, astronomers decided to take it a step further. Is anyone broadcasting anything toward planet Earth? And that's essentially what this new team led by C.D. Tremblay decided to do. They essentially conducted a coordinated, multi-step search for technosignatures, or artificial radio signals essentially, using two of the most powerful radio telescopes on the planet, the Very Large Array and the Meerkat telescope in South Africa. And here this was not just some kind of a quick peek. They monitored this planet for a pretty long time, and across multiple frequencies, specifically between 544 MHz and 10 GHz, and basically covering the entire full orbit of the planet. And their main goal was to try to see any kind of a narrow band signal, which would basically be a signal focused on a very specific frequency. So essentially kind of like what we get from radio stations. And that's because pretty much most natural objects, such as for example pulsars, galactic clouds, or even black holes, tend to emit a broadband radio signal that's much more chaotic and contains a lot of extra stuff. And so detecting some kind of a thin, sharp signal would be extremely difficult to explain using some kind of a natural phenomenon, which means that it could be some kind of an alien technology. But in most of these studies, and especially in the last 10 years or so, the biggest challenge has always been filtering out the noise. And that's because the advances in telecommunication and the huge number of different satellites such as Starlink orbiting the planet have now made radio observations super challenging. And so trying to get rid of all of these signals has now become exponentially more difficult than ever before. And to remove this radio interference, and to basically find some kind of a real signal from K2-18b, the team used a very strict data pipeline with 5 major filters. And in case you're wondering what those filters are, first, the RFI masking, that automatically throws out any signal that matches frequencies known to be used in Earth-based technology. Second, the Doppler drift, which is the result of the rotation of Earth and the movement of K2-18b, which basically suggests that any real signal should be drifting just a little bit and that drift should be observable, with any signal that's not drifting being discarded as well. Then we had the signal-to-noise ratio, basically ignoring any signals that were just too weak, or any signals that were too strong potentially coming from something nearby, and 2 additional procedures that were actually kind of clever. First, multi-beam analysis. They basically pointed the telescopes at this planet and other nearby stars simultaneously. And if a signal appeared in all of the beams, it was clearly just the interference hitting the telescope from the side. But a real signal should only appear in the beam pointed at this specific planet. Then they also conducted a transit filtering. Or basically, they noted that a signal from a planet should disappear when the planet passes behind the star. And because we know when the planet passes behind the star, they were only looking at signal that disappeared during this time. And well, in the end, they got some signals, but nothing that basically says, hello, I'm an alien. And so after processing millions of potential hits, none of them passed all of the filters, and none of them contained this narrow band frequency. Out of millions of signals, every single one of them was identified as either terrestrial interference or an artifact in the telescope. So essentially here they had a null result. But by not finding anything, astronomers have now also been able to place a kind of a limit, and specifically an upper limit, on how powerful a transmitter could be in that particular system. In other words, there still might be something here, but just without a powerful transmission. Specifically, they calculated that if there is anyone living here, they are not broadcasting with anything more powerful than a typical reader like the Arecibo reader that collapsed a few years back. But much more importantly for similar studies, this was also an important proof of concept. Since we now have larger telescopes that are being constructed, such as for example the Square Kilometer Array, by developing these filtering techniques, SETI researchers can now actually use this for a lot of additional observations and systems, where thousands of worlds can be scanned much more efficiently, and produce results very quickly. In other words, even though they found nothing in this case, this is still a pretty exciting study for a lot of future discoveries. As a matter of fact, a lot of SETI researchers now believe that these null results are technically super important. For example, one of the other studies by Daniel Engerhausen argues that a lot of these failed results and a lot of these empty searches provide us with a lot of necessary statistical data regarding how common or how rare life might be in a galaxy. With the team behind his study even going as far as determining that if scientists survey 40 to 80 exoplanets and fail to find life on any of them, it would actually imply that fewer than 10 to 20% of similar planets potentially have life. In other words, the more life we don't find anywhere, the more accurate our statistical results become, and the more specific our search becomes in the future. And so ultimately they conclude that the search for life is not just about finding some kind of an answer, but also about asking the right questions, because by quantifying these uncertainties, we also slowly start to better understand our own place in the universe, as it helps us understand the chance for our own existence. You can read about the study and some of these propositions on the SETI Institute website in the article titled, "What if we find nothing in our search for life beyond Earth?" And so in essence, the argument here is that all of these SETI searches and all of these searches for extraterrestrial life and biosignatures are definitely not wasted effort. Even if there's nothing out there, all of these additional results and studies will eventually help us understand ourselves much better. But when it comes to this planet and when it comes to the discovery of DMS here, well, it still remains a kind of a fascinating target, because there is still a hope for some kind of an ocean on the surface, even if this ocean contains no life. This still remains one of the best targets for possibly discovering water somewhere out there, and the best target for understanding these bizarre sub-Neptune worlds that we just do not have in the solar system. And so even though as of today we haven't heard anything exciting and life-related from K2-18b, we are definitely getting much better at listening and at analyzing all of these exoplanets. On that note, once we discover something else, we'll come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.